All right, hello everybody. This video I'm going to show you how to prepare large models for 3D printing. So I'm partnering with the Department of Kinesiology, Nutrition, and Health at Miami University. They're interested in acquiring more accurate anatomical models for cheaper, and 3D printing and a little bit of CAD know-how are going to help that become a reality. So we're looking at a foot bone that I downloaded from the National Institute of Health's 3D webpage. And I did already a few things to this model. I scaled it to average adult male size. So it's, I want to say, let me look here. DIM is the Rhino command for taking a dimension, but only a rectilinear dimension, so it's 266.7 millimeters. And if I use the calculator, 266.7 divided by 25, 266.7 divided by 25.4 is 10.5 inches. That's kind of what I thought it would be. So it's a 10.5 inch long foot. And I took the model, the original model that I downloaded, and I used a surface like this, converted it into a mesh, divided the foot into two parts because I'm going to be printing this on a Bambu A1, and the build volume for the A1 is 9 by 9 by 9. So this is too big for that. But if I divide it into smaller parts, that'll make printing a lot easier. And I can fit the parts together like this. So if I select, there's one more thing I did after I divided that original model. I used the shrink wrap command. The original model was a little bit blocky anyways. It was kind of low res. Shrink wrap actually added some smoothness to the model, so that was fortunate. I'm going to use the hide command to hide that front part of the foot, and now you can see on this portion there are these two diamond-shaped blocks, and if I click on this block, you can see that it actually goes halfway into the foot bone. So this is what I'm going to do. I'm going to use the command mesh boolean split, and the command line says select objects to split. That'll be the foot bone, enter, and then the diamond-shaped block, enter. And if I click on this block and hide it, so hide in the command line, now I can isolate just that portion of the block and cut a hole into it like that. So I'm going to do the same thing over here, mesh boolean split, select the foot bone, enter, and now select the diamond-shaped block, enter. I'm going to hide the diamond-shaped block and just select the portion that was left over and delete it. And now I can use the command show to bring back all the hidden objects, and I'll hide the other part of the foot bone and repeat the process on this side. So mesh boolean split, select the foot bone, enter. Now select a block, enter. I'll hide that block, select the remaining portion and delete, and there we go. A quick way to re-equip the previously used tool or command is just to right click if you're on Windows, or so it's right click or it's control click on Mac OS, but I forgot the previously used command was hide, so I just got to type mesh boolean split again. Okay. Excuse me. So here are, this is how we're going to build it. If this foot bone or this part of the foot bone remains perfectly, if it remains oriented this way while it prints, I won't need any supporting structures to be built inside of here to keep these surfaces, you know, the Bambu A1 can print models without support structure on angles 45 degrees or steeper. It's when the angle is shallower than 45 degrees that you really need support structures. But I've tried this before and it does work. It's not a like if you actually take the model and measure the angle, it does depress a little bit, so it's not a perfect 45 degree angle, but it's very close. And these little, these diamond peg blocks that we're going to print to put in there to make a kind of a rudimentary interlocking joint, let's say that it's not a perfect fit. There are easy, quick ways of adjusting those little pegs so that they do fit. And, even if the interlocking joint isn't perfect, nobody's going to know because they're not going to see it. So, okay, let me bring all these back. I'm going to copy and paste this foot and bring it over this way a little bit because I want to test some things out. From the top viewport, I'm going to use the mirror command and make so I had the right foot, now I've got the right and left. And with just this foot, or this front part of the foot, I think I'm going to try printing it just as it is. Let me try it. Let me see something here. Okay. So, let's see. Printing, also, my viewport camera focal point is kind of in a weird place. So, in the Set View tab, I'm going to use Move Camera Target to Object. Now the viewport camera is a lot more responsive. So this part I'm going to print just the way it is because it's nice and shallow, and printing things really tall, especially if they don't have a really big solid base, that doesn't work out very well most of the time. So I think this should be fine the way it is. But this part, I think what I want to do is print it with this side facing down, and I know that may seem risky, but I think that's maybe the best option. So before I do that, I want to make sure that the top surface here is really, really flat. It looks flat enough the way it is, but I think there's something I can do to make it even better. In the Mesh Tools tab, I'm going to use a mesh plane and go to the front viewport for a second, actually top viewport. I'm going to make this mesh plane kind of like that and select it. Now move to the front viewport, and so this is the initial one. This will be printed alone, so these are the correct items to look at here. I'm going to use the command mesh, let's see, what do I need to do here? Mesh trim, and I'm going to use that plane as the trimming object, enter to confirm, and now I'm going to select this top part of that mesh. Did it work? Let's see. Maybe oh. I trimmed away the wrong part. Okay, let me try that again. Maybe I don't. Maybe it needs to come down a little bit more. Let's try. Mesh. Mesh trim. There we go. It just needed better overlap. Okay, now I can get rid of this plane. And I gotta, these holes, these open holes, those are no good. So I've got to use the command fill mesh hole, which is an awesome command because just one click and it takes an open mesh. Whoops, what happened there? One closed mesh. It doesn't look like a closed mesh. Either it genuinely is a closed mesh or it's got a display problem. Let me try fill mesh hole again. That just, you see what I mean? This doesn't look good. This doesn't look right. You know, it says, the command history says it's one closed mesh. I think the way it's being displayed is kind of weird, and it doesn't look like a closed mesh, but if it says that it is, I'll take it at its word. So, same routine over here. Fill mesh hole. That looks good. I'm right-clicking to re-engage fill mesh hole. Yeah, same thing here. One closed mesh though. Here's like the actual model. It's good to inspect things thoroughly, but the command history is very accurate. So it says it's closed. The reason that matters is because a closed polysurface, a closed mesh, these are suitable for printing. If all you need is rendering, it doesn't really matter. But and there are some occasions where an open mesh can print, but some weird stuff happens in the process, and it's sometimes not as structurally sound. So, all right, with these two back parts of the foot bone, I'm going to rotate them 180 degrees. This way they can print like that. And then these two will print together this way. Now, before I export these for printing, I need to make a material boundary that is indicative of my printing volume. So 9 by 9. Oops, that's millimeters. Or inches. Let's see. Calculator. 25.4 times 9 is 228.6. So, oops. 228.6 by 228.6. So this rectangle is our build area. So I could probably do this. I'm going to copy and paste that, and I think I can, yeah, I can do these fronts first and then the backs. I think that's probably how I'm going to try it. All right, so when I'm ready to print something that I've been modeling in Rhino, I'm going to select just the things I want to print, like that. And I've probably, in other videos, I've probably covered this too, but the way that you make click and drag selections in Rhino, the direction that you make your box actually counts. So I'm going to make a click and drag selection box from left to right, but I'm only going to partially cover the objects like that. From left to right, only partially cover the object. Nothing is selecting here. If I click and drag from left to right, Rhino wants me to cover the entire objects with that selection box in order for it to select. So if I just want the left foot, even if I'm coming into the right foot a little bit, I've got to cover the entire thing. I can't do a partial. But if I go from right to left and only partially cover the object, it selects with partial. So it knows the difference between those two things, and you can be a lot pickier when you're going from right to left. It gives you a chance to sort of make a selection box and avoid selecting some other object you don't want in your selection. Okay, so now that I've got these two parts selected, I'm going to go to File, Export Selected, and keep this in a familiar location. And it has to be, for the file extension, instead of .3dm, it has to be stereolithography.stl. And I'll call this foot bone. I'm sure there's a more scientific name. I don't know what it is, though. I just know how to print it. So foot bone, front, right, and left. And the export options, binary is fine. I'm sure I've tried to export something as ASCII. I have no idea what that is, but I've never had a problem doing it as binary. So now I can open Bambu Studio, and if you're printing on another machine, you'll want to make sure that you have the appropriate slicing software for whatever kind of printer you're working with. Okay, so I'm going to go to Prepare in Bambu Studio, File, Import, and then import this long list of file types. And now I'm going to look for footbone, front, right, and left.stl. And I don't have to scale them because typically 3D printing slicing platforms are thinking in terms of millimeters. And my Rhino document, you can see on the bottom of the interface, it tells you the units that you're working in. If I was, generally I work in inches in Rhino because I think in inches, but if I know I have to build a very precise model, I'll go ahead and work in millimeters, even though I have to do a lot of conversion in the process. But I think this is going to work, so I'm going to do for strength down here. I'm going to do for sparse infill density, I'm going to double this, so instead of 15%, it'll be 30%. And for support, I'm going to turn supports on, and you really consider, yeah, there aren't any places so that they're touching the build plate only. That's going to guarantee that it doesn't try to fill in those little rectangular or those diamond-shaped openings with support material. It's not like it would be the end of the world if it did, but it would be tough to pick out those support structures and then sand. You know, it would be a whole laborious process if it did build supports in there, and I would very much like not to deal with that. So on build plate only, It's going to be tree supports. And yeah, I'll start with this. So slice plate, and before I print, I want to use the little preview bar that shows you each layer. Here in just a second, when it's done, I'll show you what I'm talking about. Okay, so Bambu and a lot of other programs will tell you if there's a major problem. It'll give you a little warning and tell you what it is. So right here, if you drag down on this bar, you can actually see what each layer of print is going to look like. And it's good just to, you know, especially with very sensitive models, to give it a once over and just make sure that you don't notice anything weird. Okay, that's it. That's my process at the moment for building these. Oh, there's one more thing. I might do this in a separate document, but I'll want to print the little diamond-shaped blocks. I did save them in Rhino, so as long as I can import them here, I can print them. All right, thanks for watching.